bucka. Haha. You know the deal.
The next thing we're going to talk about with fractions is dividing fractions. But before we talk about dividing fractions, we're just going to talk a little bit about multiplication again. And as we talked about in multiplication, when we say the word of in an English sentence and we're translating that into a math sentence, the word of usually translates into multiply. So if you're asked to find, for example, half of a number, that really means you're multiplying that number times a half. So if we have to find half of 8, for example, well, if I translate that into a math sentence, that would be a half times 8, or 8 times a half. So, as we talked about with multiplying fractions, in order to multiply fractions, we need to just have fractions in the question. So first I need to write 8 wholes as a fraction, which would be 8 over 1. And now with multiplying, we just multiply the numerators and multiply the denominators. We could reduce in this question first if we wanted to, but I'm going to reduce the answer instead. So 8 times 1 is 8, 1 times 2 is 2, and then we have an improper fraction there, so we have to change that to a number, usually a mixed number. In this case, though, 8 divided by 2 is just 4. So when we're finding half of 8, we're timesing it by half, and the answer is 4. Similarly, if you're asked to find a quarter of something, it means you're multiplying it times 1 over 4. So if you had to find a quarter of 12, it would mean that you're multiplying 12 times 1 over 4. And just as with the last example, to multiply a whole number times a fraction, well, we have to change that whole number to a fraction. 12 is 12 over 1. And then we just multiply the numerators and multiply the denominators. Again, we could reduce here in the question, but I'm just going to reduce the final answer. 12 divided by 4 is 3. So a quarter of 12 is 3. Well, with each of these examples, if I asked you to calculate a half of 8 for the first example, I would imagine that you probably wouldn't do it like this. If I asked you what half of 8 is, you would probably tell me it's 4. And how would you get that? Well, you would divide by 2. So instead of multiplying by a half to find a half of 8, you would do 8 divided by 2. And the answer to that is 4. Well, this question does involve fractions. It's just that they're all whole numbers. 8 is the same as 8 over 1, and 2 is the same as 2 over 1. And our answer is 4 over 1, but I'll just leave that as this fully simplified answer, which would just be 4. Similarly, with the second question, if I asked you to find a quarter of 12, you probably wouldn't have done it this way either. To find a quarter of something, you usually have to divide it by 4. So to find a quarter of 12, you do 12 divided by 4, which is 3. And once again, this question does involve fractions. Our whole numbers are just written over 1. So here I've taken the two examples that we've looked at. In the first one, we found half of 8. And initially, we multiplied. We did 8 over 1 times 1 over 2. And when we multiplied and then reduced, we found the answer was 4. But then we talked about how when I ask you to find half of something, really what that means is you're dividing by 2. So what we can see with these first two questions here is we've essentially got the same question. Finding half of something means you're timesing it by 1 over 2. But finding half of something also means you're dividing it by 2, or 2 written as a whole number is 2 over 1. And the result is the same. Either way, we get the answer of 4. Similarly, with the second question, when you were asked to find a quarter of 12, well, of means times. So initially we did 12 over 1 times 1 over 4. But again, realistically, when you're asked to find a quarter of something, you're probably going to divide it by 4 or divide it by 4 over 1. So these two questions, again, are exactly the same, and the result is the same. We end up with 3. So whether we multiply by 1 over 4 or divide by 4 over 1, the answer is the same. So if we look at these two examples that we have here, what we want to try to explore here is a relationship between division and multiplication. And we can see that there is a relationship here. And if we look at the first numbers in each of the questions, you'll notice that for both of these examples, the first numbers don't change. They stay the same. But the second numbers do change in order for the question to remain the same. So really what we're doing here is we are changing something. It's the same question, but it's written a different way. So initially we have a division question when we're dividing by 2 over 1. And what we can see here is if we multiply by 1 over 2, the result is the same. Similarly, in the second one, we are changing to multiplication from division. The first number stays the same, 12 over 1, and 12 over 1 doesn't change. But the second number does change. The first, initially we have 4 over 1, and then that changes to 1 over 4. But again, the answer is the same. So what we start to suspect here is, can we do this with other fractions? Well, let's explore another example here. So suppose we have the division question 1/2 divided by 1/4. Well, if I follow the pattern that I've had in the previous two questions, I can rewrite this as a multiplication question. So I'm going to change division to multiplication, just like in the previous two examples. And just like in the previous two examples, I'm not going to do anything with the first number. We're going to leave it exactly the same. The second number, however, I am going to change. So if I look at how these fractions change in these two examples, it looks like what happens is the fraction is flipped. So in this case, I have 1 over 4 in my division question. So I'm going to change that to 4 over 1 in my multiplication question. So let's go ahead and answer that multiplication question by following our rules for multiplying. And we get 4 over 2, and 4 over 2 equals 2. So the question is this the correct answer for this division question? Is that in fact what 1/2 divided by 1/4 equals? Well, if we think about what division means, a division question is really asking how many of one value fit in another value. So, for example, if we ask the question 8 divided by 2, again, we're asking how many 2's can we fit into 8? And we can fit 4 2's into 8. Well, similarly, if we go back to this question, we're asking how many quarters can we fit in a half? Well, what you can see on the board is I've drawn a half, and if we ask how many quarters are in that half, I have to split that half into quarters. And if I split that half into quarters, or if I split the whole pizza into quarters and see how much is in that half, you can see that I've got 2 quarters in a half. So the answer to this question is 2. So what we can see here is that by changing to multiplication and flipping the second fraction, we end up with the correct answer. So here's the 3 examples that we've taken a look at so far. And so once again, what we can see is that when we're dividing fractions, we can write an equivalent multiplication question, but we have to change the second fraction. And what we have to do to the second fraction is the first number, or first fraction, always stays the same when we're changing from division to multiplication. but the second fraction we flip. And there's a term that we use for flipping a fraction, and it's called a reciprocal. So all of these examples here, 2 over 1 changing to 1 over 2, 4 over 1 changing to 1 over 4, and 1 over 4 changing to 4 over 1, those are all examples of reciprocals. So let's try another example. Suppose we have 3 over 8 divided by 1 over 5. So with dividing fractions, there really is only one rule for dividing fractions. We don't divide fractions. Because of this property that we've explored with these 3 examples, we don't have to divide fractions. We can change to multiplication. Well, if we're going to change from division to multiplication, something has to change, because dividing is not the same as multiplying. But as we've seen with all of these examples, as long as we leave the first number the same and change the second number to its reciprocal, the answer is correct. So now I follow my rules for multiplying. 3 times 5 is 15, and 1 times 8 is 8. So here we have a case where we've got an improper fraction, so we'll go ahead and change that to a mixed number, which is 1 7/8. So once again, our only rule with dividing fractions is we never divide fractions. We change division to multiplication, and we change the second number to its reciprocal. Let's look at an example where we have some mixed numbers here. So just like with multiplication, our only option with mixed numbers is to change them to improper fractions. So usually I suggest you do that first, always, with any question. With addition and subtraction, you do have some other options, but typically, if I've got a question that involves fractions, I only want to have fractions in the question. So I want everything just written as a fraction first. So when we change these to improper fractions, 3.5 is 7 over 2. And it's still a division question. I'm not going to change that yet. We're just changing these to improper fractions. And 1 1/5 is 6 over 5. Well, now that we've got the question just written as fractions, I'm going to follow the rule for dividing, which is I never divide fractions. I multiply. The first fraction stays the same, and the second fraction changes to its reciprocal. So 6 over 5 changes to 5 over 6. Now when we follow our rules for multiplying here, we multiply straight across. 7 times 5 is 35. 2 times 6 is 12. We have an improper fraction here, so we'll change that to a mixed number. I think that's 2 and 11/12. So the original question was 3.5 divided by 1 1/5. We followed our properties for changing division to multiplication. These 3 questions that we have here are all exactly the same question. But the only one that we can really solve is the last one, is the multiplication question. But the answer to that original question is 2 and 11/12. Because all 3 of these questions are the same question, so they all have the same answer. So to finish off our lesson on dividing fractions, I'm going to go ahead and get you to try 3 examples here. So each one of these questions is a division question that involves fractions in some way or another. So what you're going to want to do is go ahead and change it to a multiplication question and change the second fraction to its reciprocal. For question 2 and 3, we are going to have to write everything as a fraction first. If you're able to answer that, congratulations, you now have a firm understanding of how to divide fractions.